record. Here we are. We are going to work on SQL, Structured Query Language. Structured Query Language does four things. In a database, we create, we read, we update, or delete. That's why it's called CRUD. Don't you like acronyms that computer programmers come out of?
Kind of like poop.
Yeah, kind of like poop. So we're going to create a relational database, and some of you have or are taking Access, so the visualization and Access is much better than this. SQLite is a very simple database engine. It's not even really an engine. It's just a file that sits there. It's used a lot in little applications on your phone and all kinds of little toy applications. It's kind of easy to work with because there's very few data types. You either have an integer or you have a real or you have text, and those are the three we'll work with. We're not going to use blob. Blob is if you want to store an image or music or something like that. So in SQLite in Python, because we're going to be taking integers from Python, putting them into SQLite. We'll be taking floats, putting them into real. We'll be taking strings, putting them into there. We will get our input from Python and then store it in SQLite. So we have, I guess, permanent storage, longer lasting storage, maybe is a better term. It's non-volatile storage, if we want to be technical. When you're designing a database, in the olden days, this is how we stored things. We'd have a big long table, a single flat file. We'd have all the information in here. And if these people bought something, they would have everything in there. You'd have stuff duplicated all over the place. So let's go to our friend, Mr. ChatGPT, and we'll do a practical example here. I don't know if he's your friend or not, but he better be. So we're going to create a flat file table of the typical fields that would be in a, we'll just say in a, what, convenience store. Convenience, oh boy. Oh brother, convenience store, point of sale. That's what POS stands for, point of sale. Or a Pizza Hut or whatever, there we go, convenience store. And that's what it used to be called, as a flat file. It's CSV type. Oh, look at all that stuff. So look at all the things that if you had to store all of this stuff, you suppose you would have duplicates of item description. You suppose you'd have duplicates of cashier ID. If you are storing this as a flat file thing, anything that is in there more than once, like every time you do a transaction, right, you're gonna have to store the store ID. So you have to store it again, and you have to store it again, and you have to store it again, which doesn't make any sense. Yes, I would like a, yes. Give me a CSV. It even talks about normalizing in there. Oh, I have to log it. Yes, show me. That's all I want to do is just see it. There we go. There. Doesn't look pretty, but that's what CSV formats look like. So look at all the duplicate data. So duplicate data is not our friend. And how would I find out all of the transactions that were made by register 2 over the last 3 days?
Query.
We can't do a query on this. You'd have to do a filter or something, because this is a flat file. This is an Excel spreadsheet. So this is what everything starts out as you're defining your database. You want to make sure you figure out all your data fields. And that's fine. That's the first step. And that's where databases were originally. They didn't have relationships or anything like that. They were called a flat file or a CSV file. So this is like a single table. Well, a single table doesn't let us really do much. Because what if I want how many things that employee 789 sold on register 1? I have to have some way to connect those together. It's not easy. We don't need a download file. I just wanted to show where we're starting. So that's where this starts. Well, the first thing you do, and it's called normalizing. Does Jackie use that term, normalizing? Probably not. Okay, so normalizing means that we're restructuring the data. We don't want duplication. So we take a look at this. What in here is duplicated?
Probably the same.
The employee name is duplicated, the department ID is duplicated, the department name is duplicated. What is not duplicated?
Employee name.
John Doe, John Doe.
The employee ID.
Yes, employee ID. Employee ID would be something that would be called a primary key. Primary keys, the best primary key is one that does not mean anything. In the old days of going to school, they used to use your social security number. Well, that's not such a good idea. It should be just a randomly drawn number, like my ID here is 2903. Doesn't mean anything, and that's a good primary key. It has to be unique to identify each record. So this is the fields, this is each record. So it is redundant. So we've identified it, and you can see by looking at it, we have employee information and department information in the same place. So if we're going to break this out into two tables, what might be logical tables to do that with, to break it into? What pieces of information go together?
The employee name and then the
Employee name,
ID.
Employee name, department ID, then name, department name.
so if we had two tables, what would they be called?
Employee and department.
Exactly, because these go together, these go together. Department ID is also a primary key. It's unique. So we'd end up with the original table. So we extract the information, and now we have two tables. Right? There's no redundancies here. And the convention I use when I'm doing field naming is I do like a 3 or 4 letter initial, so I know what it is, like DPT is short for department, EMP is short for employee. You'll see why I do that when we start writing queries and things. If you just have name, how do you know what it is? And if you type in department name, well, the name gets really, really long. So this is just a convention. So these are the definitions of these two tables, right? But notice, what did we add to this? We have our primary key, we have our primary key. What in the world is this here? What is that for?
That's just linking your department to your employee.
Yep, I don't have to have sales here 50 times for all the 50 salesmen. I link it to this table. This is a foreign key, which connects up to this primary key. And then I can put in all kinds of extra fields that describe the department if I want. I only have to do it once. That's the idea of a relational database. You should only have to enter the information once. And now I can do a report on employee ID 1, or how many employees are in the sales department. I don't have to filter things like in a spreadsheet. I can do a query now, which we'll get to that. Then we have talked about the relationship. When you're designing a database, this is one of the things that's really important. There's actually positions that's what they do. They're called business analysts, or that's probably the most common term. They take the customer request, analyze it, and put it into and go through and design what the program and database is going to look at. So business rules are a good way to describe the relationship. So in this case, this is not actually real, but it's what I did for this. A department can have many employees. So that's a one to many. An employee can only be in one department. I didn't say multiple employees can be in one department because that's a whole different thing. We're pretending that an employee can only be one department. I'm just keeping it simpler. Once you're going to express it in business rules, that makes the rest of it easy. One to many, one to one. All right. So this is the talking way of describing how they're connected. This is the drawing way of how you describe how they're connected. There it is. There's my music library. So I have an artist ID, which is the primary key for this, and primary keys are always integers. Can't have floats because floats are not definite. Floats go forever. So integers are definite. It's either a 1 or a 2 or a 3 or a 4. This connects my 1 to many, right? So song ID is primary key here. This foreign key, art ID, connects to this guy. So the number 1 artist ID connects to this. So we could have multiple songs by the same artist. So far, so good? This is called a crow's foot diagram because this is supposed to look like crow's feet. I think that's what it looks like, right? So you can do this in any number of places. I can't remember what I used. I used lucid.app because it's really easy to use, but you can only do so many diagrams. But that's what I used. So you are going to design your own database of some sort that is similar to this. We only want 2 tables. We want a one-to-many relationship, and that's it. And then you're going to do business rules. Right, we'll draw a little thing like that. Here is a sample data in a spreadsheet. So this is the assignment, put some sample data. This is my database. Determine the entities. Tables are referred to as entities because it's something that contains information about a thing or an object. So artist. Well, this is information about the artist. Is this information about the artist? No. Again, nope. It's all about the song. So we have how many tables here? How many entities we have? We have artist and we have song. Those are our 2 entities. And we're pretending that a song can only have 1 artist, which in this case, that works, doesn't it? Typically. And then also, if you do something with music, you have to sing the song. So that's part of what you want to record. Okay. I guess not, huh? Oh, got it. Okay. So we want sample data in a little thing like this. Make up your own idea. We want business rules. We want an ERD because planning the database is very important. After your database is in production, how easy is it to go in and change things? Yeah, not so much. We want to get it planned right in the first place. We can add and extend things, but we can add more fields to song name. We can add more fields to the artist, but like to rearrange the relationships, that would break a lot of stuff.
And that's the only part we're doing.
This is all we're doing this week.
So we don't need to do part 2 or part 3.
Oh, where's my, oh yeah, right here. Yeah, that's the next piece. A data dictionary just takes basically your fields and defines what sort of information it is and a description of it and whether it's a primary key or not. Whenever you're trying to figure out how to work in a database, data dictionary is really handy to know so you know what the heck each of those mean. Alicia and I did a project with the reporting software for the college. They did not have a data dictionary.
Really?
They had what they thought was a data dictionary, but it was not. It just had the names. We had no idea what some of the fields were. And how do you do a report if you don't know what the fields are? That's what this is for. If I want to find out, but my fields are named and they make sense. You should see some of these fields in our colleague program. Oh my gosh. It's just like they store things in 20 different places. It's just was impossible to figure out. We did eventually figure things out and we documented the stuff that we were looking for our project in a data dictionary and passed it on to the people that are there now. That project's over, thank goodness. That was very frustrating because nothing was documented. But that's the next part. Then we create the database in SQLite. So yeah, that's it. That's all we're doing this week. What do you mean that's all you're doing? You can't